first remind ourselves, let's remind ourselves of the rational roots theorem, which says that if a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus etc. down to a1x plus a0 equals 0, with all of the coefficients coming from integers, then the only possible rational solutions of this equation are of the form p over q, where p is a factor of the constant term and q is a factor of the leading coefficient of the polynomial. Okay. Then, if we wish to show that the cube root of the square root of 2 minus 1 happens to be irrational, we could start this proof by saying let r equal the cube root of radical 2 minus 1. Then cube both sides. R cubed is equal to radical 2 minus 1. Then add 1 to both sides. So then we'd get that r cubed plus 1 is equal to the square root of 2. Then we could square both sides. So that then the r to the 6th plus 2r cubed plus 1 would be equal to 2. And finally, we could then say, by subtracting 2 from both sides, that r to the 6th plus 2r cubed plus, minus 1 would be equal to 0. Therefore, the number r would be a solution or root of the polynomial f of x equals x to the 6th plus 2x cubed minus 1. Right? Because we just showed, or we set up a polynomial so for which when we plug in r, we see r to the 6th plus 2r cubed minus 1 equals 0. So this particular polynomial would have a root of cube root of square root of 2 minus 1. Okay, so now let's look at that polynomial more specifically. The only possible rational solutions of x to the 6th plus 2x cubed minus 1 equals 0 are plus and minus 1. But notice that f of 1 would be 1 to the 6th plus 2 times 1 cubed minus 1. In other words, 1 plus 2 minus 1. And negative 1 to the 6th plus 2 times negative 1 cubed minus 1, which is 1 minus 2 minus 1, which is equal to negative 2. And notice that neither of these are equal to 0. So the only two possible rational candidates for roots of this polynomial didn't work, and therefore r, which was equal to the cube root of radical 2 minus 1, must not be rational, and therefore it must be irrational.